Welcome students. Today in this video we are going to discuss algebra of sets under this chapter sets or set theory. Okay, so we are going to discuss this laws, associative laws. Okay, so associative laws, there are two laws. First, A union B inside the bracket union C is equal to A union B union C inside the bracket. Okay, and second law is the union operation will be replaced by intersection. So in second law, in place of union we will write intersection, so you can remember it easily. So this is A intersection B in bracket intersection C is equal to A intersection B intersection C in bracket. Okay, so these two laws are known as associative laws. So this is associative laws for union of sets, this is associative laws for intersection of sets, correct? And as we know from very beginning that if any operation is given inside a bracket, then we should address first it, we should solve first it. Okay, so here in left hand side we will first find A union B, and in right hand side we find first B union C. Okay, and the property of sets which you will be using here, that we are going to use, is that when any set is said as subset of another set, so this is a property that if X belongs to any set A implies that X belongs to another set B, then we can conclude A is a subset of set B. Okay, why so? Because subset is that set which contains only those elements which are available in set B. So if any element belonging to A implies that all these elements like X are also available in B, it means A is a subset of B, correct? And second property that we will be using here, that if A is a subset of B and B is a subset of A, this implies that set A is equal to set B, correct? Two sets are equal if one set is subset of another, and converse is also true. Second set is subset of first set. So if A is a subset of B and B is a subset of A, it will imply that A is equal to B. The same thing we will apply here, that this set in LHS is a subset of RHS and RHS is a subset of LHS, then both the sides LHS and RHS will be equal. So first of all we will show that here LHS is a subset of RHS, and second step we will show that RHS is a subset of LHS, and by combining these two results we can conclude that set in LHS is equal to set in RHS. Okay, so now let us see the proof of this first law, which is A union B union C is equal to A union B union C. Here B union C is bracket. So now let us use this property here. So let X belongs to this left hand side, A union B union C, and this implies that X belongs to A union B or X belongs to C. You know that if element belong to any one of these two sets, it will belong to union of these two sets here. Okay, now we can expand it by the same property. X belonging to A union B means X belonging to A or X belonging to B. So this implies that X belongs to A or X belongs to B or X belongs to C, correct? Here this is in bracket. X belongs to A or X belongs to B, this will be in bracket due to this bracket. Correct? But if you write the same statement, only we change the bracket, then its significance will not change. Its meaning will not change. It will remain same. So this implies that simply we are changing the position of bracket. Why we are doing so? By looking at the right hand side, that here B union C is inside a bracket. So instead of keeping bracket for X belonging to A or X belonging to B, if you shift bracket from here to here, the statement will not change. Okay? So this implies that X belongs to set A or X belongs to set B or X belongs to set C. Hope you understood it. Okay? Just we are shifting the bracket, and this implies that X belongs to A, or here for this statement X belongs to B or X belongs to C, we can write X belongs to B union C. Correct? Now you see here X belongs to A or X belongs to this set. So if any element X is belonging to either of these two sets, X belongs to union of these sets. So this implies that X belongs to A union in bracket B union C. So bracket has been shifted due to this step. Let us call it. Okay. So what does it show? We can conclude here. You see that X belonging to a set in LHS also belonging to set in RHS. It means set in LHS is subset of set in RHS. This property. Okay, first property. So this, therefore, here A union B union C is a subset of A union B union C. A union B union C in bracket. Okay, let us call it relation number 1. Again, we'll do the reverse process. We'll start from here. Next, let X belongs to right hand side. Here we had started X belonging to left hand side. Here now we will start X belongs to right hand side, and we will try to show that right hand side is a subset of left hand side. Okay, so let X belongs to A union B union C, and this implies that X belongs to A or X belongs to B union C. We are keeping it inside a bracket because bracket is already here in B union C, and this implies that here bracket has no such significance. Here also we can shift the bracket from last two to first two, okay, sets. So this can be written as here X belongs to A, or again this can be written as X belonging to union of two sets. So either X belongs to set B or X belongs to set C, then X is here in B union C. So or X belongs to set B or X belongs to set C. Now we will change the position of this bracket. Matter statement will remain same, so there will be no effect, and this implies that X belongs to A or X belongs to B. We are changing the position of the bracket here. We are shifting the bracket here, or X belongs to set C. This implies that X is belonging to set A or X is belonging to set B. It means X will belong to union of these two sets. So X belongs to A union B, or X belongs to C. X belongs to C. Correct? Now you see here X belongs to this set or X belongs to this set. It means X belongs to union of these two sets. So this implies that X belongs to A union B union C. Correct? Now you see here we have started X belonging to this set where bracket is given here in the last two sets, but here the same element is belonging to this set but bracket is here. So what does it show? What is implies by this property? X belongs to A implies X belongs to B, means A is a subset of B. So similarly X belongs to this and implies X belongs to this, means this is a subset of this. So this implies that A union B union C is a subset of A union B in bracket union C. Let us call it relation number 2. Now we can apply this property. If A is a subset of B and B is a subset of A, this implies that A is equal to B. The same thing we are getting in relation number 1 and 2. Here LHS is a subset of RHS. Here RHS is a subset of LHS. So by combining relation 1 and 2, we will get, now we are using this property here. So we can write here that A union B union C is equal to A union B union C in bracket. So we are getting the result. We have proved it. Okay. So little bit logical but not difficult. You can understand it very easily. Just you make some practice, at least 2-3 times you write on your notebook, you will be very clear. You can do this solution very easily. Okay. This second law. Here second law is A intersection B in a bracket intersection C is equal to A intersection B intersection C. So we are leaving this proof for students, for you people. Okay, you can do it very easily on the same pattern. The only thing that in place of union you have to put this intersection sign. Okay, and in place of this word or, we have to use another word which will be and, due to this intersection. So this is left for your exercise. The only point you have to take care that in place of or in part 1 we have to use and. We can prove it and we can get the solution very easily. So students, hope this is very interesting. You got it properly, and I hope you might have subscribed my channel. If you have not subscribed yet, please do it immediately and remain in touch with all these videos. We'll produce these videos in a very interesting manner. So be in touch with these videos and enjoy learning mathematics. Thank you very much. Wish you all the best.